Hello all. So we are meeting again for video on information retrieval to find out the distance between two text documents. Yeah, to find out the distance between two text documents. So actually we are going to make use of, obviously I'll have to open my editor. We are going to make use of various terms here. First we are going to make use of the term stemming. That is also known as the Porter stemming algorithm. So this Porter stemming algorithm is a process of removing suffixes. So when we search something on the Google or any search engine, uh, for example, if I want to find out the words related useful, so it can be, or it can be, say, use. So it can be something like useful, uselessness, usability, something like that. So useless. So these are the words which are related. So whenever we are searching something on the search engine, obviously it doesn't take the word which you have searched for, but it removes suffixes and then tries to search based on that particular original word. So that is Porter stemming algorithm. We are going to make use of NLTK dot stem dot porter dot porter stemmer as function over here, and we are going to make use of the natural language toolkit library, and we are going to import that too. Then obviously, suppose if I want to search for, or we can give some other example. Say I want to search for the word fish, then it can be fishes, or it can be fishing. So all these words have come from fish, right? We are going to talk about one more thing, that is TF-IDF, that is term frequency incidence document frequency. So it is something like this, in such a way that if there are three statements, say I have doc1, I have doc2, and I have doc3. So I want to search for the words, say fish, blue, blue cat, and then blue sea. So if I want to search for the word over here as blue in all the three documents, then I would have to make the document 1, document 2, and document 3 in such a way that I'm going to search for the word blue over here, and if it is present in doc 1, then it would be 1. If it is present in doc 2, then it would be again 1. If it is not present in doc 3, then it is 0, but in my case it is present, so it will be 1. Okay, why I explained you this? Because we are going to make use of this in the TF, the the functionality of TF-IDF in finding the difference between the two text documents. Okay, we are going to talk about one more thing, that is cosine correlation. So this fundamental has been used in this particular program in such a way that if the documents are most similar, because we are going to find out the similarity between the two documents. So if the docs are most similar, then we are going to get the highest value, highest score. And if suppose the docs are not similar, or not at all similar rather, then here it will give me the lowest value. So that is the idea behind it. So we are going to work on these concepts now in this particular algorithm for finding the difference between the two documents or the distance between the two documents. I hope you must have understood whatever the concepts I have taken till now. We can have a look again on the concepts. One is a Porter saving algorithm, that is removing suffixes. We are going to make use of NLTK library over here of Python. It is TF-IDF, that is term frequency incidence document frequency. It is something like finding which particular element or that particular token is present in which particular document. So in this manner it gets created. And we talked about cosine correlation, which talks about similar document, whether the documents are similar or not, and how much similar they are. So we will start writing the program now. So to find the similarity between two documents, this we are going to execute. We will import the NLTK library and string library. Even we are going to import sklearn.featureextraction.txt, import TF-IDF vector. TF-IDF I have told you already. Then we are going to talk about the NLTK.download punct. So punct is the punctuation remarks it understands. So it is punct. And then we are going to talk about the Porter saving algorithm or Porter saving library rather. So sorry, it should be library. NLTK.stem, I had written it a few minutes ago about the same. Porter saver. Then obviously we will have to remove the punctuations whichever we are writing with respect to the that particular. We are going to find out the similarity between two text documents. So we'll have to remove the punctuation. For that, we are going to write down on the remove punctuation map. So it will be remove punctuation map equal to dictionary of number of characters which are there in order for character is string.punctuation, and this string library we have already used on the top. We will write down a function now, stem tokens. So these stem tokens would strip out all the double quotes whichever are there, and so raw text has to be pre-processed with the most common words and punctuations removed. Tokenization and stemming, it is also known as lemmatization. So they are the concepts of natural language processing, and we are trying to learn this as a part of, actually they are the part of the machine learning, and they come under natural language processing. There is one more function we are going to execute, that is def, normalized text, returns stem tokens, and it would return nltk.word tokenize, and it would take all the characters in lowercase. It would translate all the characters in lowercase by removing the punctuation map. So punctuations will be removed from the same. Now that would be vectorizer. It is talking about the TF-IDF, which I told you, term frequency incidence document frequency vectorizer. It is going to and we are going to talk about the stop words which are in English, because we are going to run everything in English language, or we are going to give an input in the English language. Uh, Actually, when we talk about the stop words, the meaning is, if suppose I have a word, this is a book. So is not important. This is book is important. Or if I'm talking about, uh, I am teaching the programs in Python. So the is not important over here. Programs in Python is very important over here. So they are which are adjoining words, they are known as the stop words. So we are going to learn about the stop word removal in the next tutorial. So there is one more function about cosine correlation I told you few minutes ago. So it is something like cosine similarity is the cosine of the angle between two vectors. If it is greater than value 0, then we can say that there is more similarity between the documents. Otherwise, if it is less than the value of cos theta, then the it is less than the similarity between the two text documents. So how I give the input, it depends on that, and it is going to run up. So it would return the value between 0 and 1 if the documents are similar or documents are not similar. If the documents are similar and same, then it would return the value which is closer to 1, otherwise it would be lesser. So that is calculated by cosine correlation, and which we have executed or written this particular function, which is going to find out the similarity between the text 1 and text 2. So I'm going to pass the input now. So this cosine sim has been called over here. A little bird and a little bird would be checked whether they are similar or not. A little bird or little bird chirps would be checked whether they are similar or not, and then we will try to execute the program. And maybe I can take one more statement where there is no similarity at all between the two documents. So I took three statements. The first one, very much similar, rather same. Second, few words are extra, and third one, not. It is totally dissimilar document. So let's execute the program now. I executed the program, and I can see here the various words whichever have been used. They are from the stop words, maybe, and it is written that they are not in stop words. And I can see here that I had a little bird. They are quite similar, so it is reaching to 1, close to 1. Chops is the extra word which is present over here, so it is somewhat similar. So that is the distance, that is a similarity score. Or and when we talk about the statements, the remaining statements, the last statement, we can see that there is totally dissimilarity, so it is 0.0. So in this manner we have tried to find out the similarity between two documents, and obviously you will have to install NLTK and string and sklearn2. In the last video we have seen how to install the libraries by using pip3 install NLTK or pip3 install sklearn. So we have seen this already. So by this you can execute these programs. Thank you very much for watching the video on the information retrieval. I will come up with few more videos on information retrieval, and we will try to execute them. So you can see here the output. Thank you very much. Do subscribe to my channel Madhvi2303.